Have you ever wondered how websites like Google, Amazon, and Yahoo are able to provide you with the information you need at the click of a button? Well, it's all thanks to databases. Nowadays, databases are essential to every business, and they play a huge role in scientific investigations as well. For those of you who may not know, a database is basically a collection of information that exists over a long period of time. Corporations use databases to maintain all their important records, and scientists use them to represent data gathered from a variety of sources, like astronomers studying the cosmos, investigators exploring the human genome, and biochemists examining the properties of proteins. So what makes databases so powerful? Well, it's a combination of knowledge and technology that has been developed over several decades, and is embodied in specialized software called Database Management System, or DBMS. DBMS is a fancy term for what we commonly refer to as a database system. These systems allow you to create and manage large amounts of data efficiently, and they are designed to keep your data safe over long periods of time. But don't be fooled. Database systems are complex pieces of software that require a lot of knowledge and experience to use effectively. They're used in all sorts of industries, from banking and finance to healthcare and transportation, and they're constantly evolving to meet the demands of modern businesses and scientific investigations. So the next time you're browsing the web or hear about a major scientific breakthrough, just remember that databases played a crucial role in making it all possible. So what exactly is a database? Well, put simply, it's a collection of information that's stored over a long period of time, sometimes even years. But when we talk about databases in the modern age, we're referring to a collection of data that's managed by a specialized piece of software called the Database Management System, or DBMS for short. A DBMS does a few things, and one of its primary functions is to allow users to create new databases and specify their functions, which is often referred to as the schema. This is done using a specialized language that's designed for this purpose. But the database management system does more than just create and manage databases. It also lets users query the data that's stored within them. In database lingo, a query just means a question about the data, and the DBMS lets users manipulate the data too, using a language that's specifically designed for this purpose. Of course, databases can store a lot of information, often many terabytes or more, and the database management system has to be able to handle all of that data efficiently. This means providing fast access to the data for queries and updates, as well as ensuring that the data can be stored safely for a long time. And when it comes to data safety, the DBMS also needs to be able to handle failures, errors, and even intentional misuse. This is what we call durability, the ability of the database to recover from problems and keep running. Finally, the DBMS also has to be able to control access to the data from multiple users at once, without allowing any unexpected interactions between users. This is called isolation, and it ensures that everyone can access the data they need without stepping on anyone else's toes. And the DBMS also needs to make sure that any updates to the data are performed completely and reliably, without leaving any half-finished transactions behind. This is what we call atomicity. Believe it or not, the first commercial database systems appeared in the late 1960s. These systems were a big leap forward from file systems, which could store data over long periods of time, but had some limitations. For example, file systems didn't guarantee data would not be lost, didn't support efficient access to data, and didn't satisfy the needs of concurrent access by multiple users. Despite these limitations, database management systems quickly became popular for certain applications. One of the earliest applications was in banking systems, where database management systems were used to maintain accounts and ensure that money didn't disappear due to system failures. Airlines also began using database management systems for their reservation systems, which required quick and efficient processing of large volumes of small actions by customers. Finally, corporations began using database management systems for record-keeping purposes, including employment and tax records, inventories, sales records, and more. Early database management systems required the programmer to visualize data as it was stored. These systems used different data models for describing the structure of the information in the database, including the hierarchical or tree-based model and the graph-based network model, which was standardized in the late 1960s through a report of the Committee on Data Systems and Languages. However, these models had limitations in that they did not support high-level query languages, which made it difficult to write programs even for simple queries. In 1970, Ted Codd published a famous paper that revolutionized the database industry. He proposed a new way to organize data, presenting it to the user as a table called relations. This structure allowed programmers to query the data in a high-level language without worrying about the storage structure behind the scenes. By the 1990s, relational database systems became the norm, and structured query language became the go-to language for relational databases. Later on in this series, we'll be discussing the relational model of database systems in detail, including SQL. But the database industry continues to evolve, and new issues and approaches to managing data arise regularly. Object-oriented features have infiltrated the relational model, and some of the largest databases are organized differently from those using relational methodology. In the past, database management systems were large and expensive software systems that required large computers to operate. This is because storing even a gigabyte of data required a lot of space. But today things have changed. With the advancement of technology, hundreds of gigabytes can fit on a single disk, making it possible to run a database management system on a personal computer. As a result, relational database systems have become available for even small machines and are now commonly used for computer applications. Another trend in database systems is the use of documents, often tagged using XML or extensible modeling language. Large collections of small documents can serve as a database, and the methods of querying and manipulating them are different from those used in relational systems. However, as data continues to grow, there are databases that store terabytes or even petabytes of data. For example, Google holds petabytes of data gleaned from its crawl of the web. This data is not held in a traditional database management system, but in specialized structures optimized for search engine queries. Satellites also send down petabytes of information for storage in specialized systems. Pictures and videos can also take up a lot of space. Repositories like Flickr store millions of pictures and support search of those pictures. Amazon's database has millions of pictures of products to serve, and YouTube holds hundreds of thousands or even millions of movies and makes them easily available. Peer-to-peer file sharing systems use large networks of conventional computers to store and distribute data of various kinds. Although each node in the network may only store a few hundred gigabytes, together the database they embody is enormous. It's amazing to think how far database systems have come and the massive amounts of data they can now store and manipulate. In the next video, we'll continue our discussion of the trends in database systems and their impact in modern technology. And that brings us to the end of today's video. I hope you found the information useful, and if you enjoyed the video and want more content on computer science related topics, be sure to hit the like button and subscribe to our channel. Thank you for watching and see you next time.